Hey physics students, this is the second half of the free fall review at the beginning of Unit 6, numbers 4 through 6, all right here on this one page. Got my calculator ready to go, probably going to need that. Alright, so rock is thrown straight up with an initial speed of 22 meters per second. How long will it be in the air before it returns to the thrower? I'm going to make my little list here. Know the acceleration is going to be -10. Initial velocity up, that's positive 22. I think I said before, probably a good habit to force yourself to write down a sign there to make sure you're thinking about the up or down. Don't know about final velocity, although if you reason that if you threw it up 22 meters per second, by the time it gets back down again, wouldn't it be going just down 22 meters per second? That's actually true, but I'm going to pretend I don't know that. And let's see, delta y, if it's going up and then down again to the same place, the delta y is 0. I have to watch out for that. And time, I think that's the first thing we want to find here. How long will it take? Okay, so that looks like the equation delta y equals 1/2 at squared plus vit. Delta y is 0. 1/2 a is -5 t squared plus 22t. There's a couple ways you can deal with this. This is actually pretty easy to solve by just factoring out a t. You could do and then algebra, so if this product is equal to 0, then either this is 0, which we wouldn't care about that. We want to know when it gets back to the ground. Obviously that doesn't happen at time 0. So then set this equal to 0, that's the other possibility. So minus 5t plus 22 equals 0. Subtract that over to the other side, so 22 divided by 5 is 4.4 seconds. The other option, if you're not a huge fan of doing algebra, that's okay. You can still, as long as you get everything on one side, could just go in and graph it. And I've already got the -5 x squared there ready to go, so plus 22t. I always look at my window settings before I do anything. So from 0 to 10, I think that window is going to work just fine for us. So graph that, and boom, there it is crossing. And I can go ahead and second calculate, looking for the 0 of that. Left bound, right bound, I could play with the arrow if I want to, but I don't want to. I'm just going to tell it to look between 0 and 10. 0 and 10. And there it is, 4.4. So either way, the problem with doing it the algebra way is if you have a number here for the delta y, here my delta y was 0, but if that's a number, then you're going to have another thing here, and then it's not going to be, you won't be able to do the factoring thing, probably. Oh, got more to do here, sorry. Graph the vertical velocity and acceleration of the rock on the axes. Vertical position, velocity, acceleration, make a well-labeled diagram of the situation, make a list of the given quantities, which I already did all that. So the little diagram of it, got a ball here, it has an initial velocity up, and then you go up and come back down again, like that. That works for the diagram. This, if I could go back and change this, instead of x, I really wish that that was a y, because this is going up and down. So it's going from the ground, it's going to go up and come back down again. It has constant acceleration, so I know from Unit 3 that constant acceleration problems, if you got constant acceleration, your position time is going to be some piece of a parabola, be a curve. And I know that velocity time will be a straight line, and it's the slope of this. So it starts out with a velocity of plus 22. When it gets up to the peak, has a velocity of 0, and then it starts going down, or in other words, having negative velocity after that. So that looks like that. This is a review of things we did in Unit 3. And then the slope, what's the acceleration? The acceleration is -10 all the time. That's what those graphs look like. Number 5. Student throws a baseball off a 120-meter high bridge with an initial downward speed of 10 meters per second. Downward speed means negative. How long does it take for the ball to hit the ground below? All right, set up my little list here. Initial velocity is downward at 10. Final velocity, I don't know. Looks like that's what we're going to find in Part B. Delta Y, the bridge is 120 meters high. Now what's this ball doing? If this is the bridge, throwing it down like this with an initial velocity of -10, and it's going to go from here to here. That is a negative displacement because it is going down. It's starting here and ending here. So you need to make sure that you put that negative sign on that. And how long does it take? I'm going to use this equation. Delta y is -120, -5t squared, and then vi is -10, so -10t. This is another calculator graphing thing. -10 plus 120. Good. And I think that the window that we have right now, as long as this thing gets to the ground before 10 seconds is up, we should be fine. And there it is. Looks like about 4 seconds. Maybe it's exactly 4. Second calculate, 0, somewhere between 0 and 10. Yep. The fact that we got exactly 4, that means this could have been factored, but I'm not interested in you doing it in that way, because lots of them don't factor, can't be factored. How fast is the ball going at the moment of impact? Well, now that you have this, 4 seconds, you could just think, if you wanted to, well, it's starting at -10, and I know that an acceleration of -10 means subtract 10, subtract 10, subtract 10 for each second that goes by. So -10, -10, -10. If you do that for 4 seconds, you're going to get down to -50, right? If you don't like that way of just puzzling through it, you can, of course, use this, which does exactly the same thing. Right? Start at -10 and then subtract 10 4 times. Or you could use this one. What's the final velocity? Well, initial velocity is -10 squared plus 2 times acceleration times that. So it could be f squared is, that's 100 plus 2400, that's 2500, and the square root of that is 50. Put the plus or minus sign on there because it could be plus or minus. We know that it's going down, so it must be the minus. So whichever way you do it, you get the same thing. When a kid drops a rock off the edge of a cliff, it takes 4 seconds to reach the ground. When she throws the rock, it strikes the ground in 3 seconds. What initial speed did she give the rock? Okay, so I'm just going to focus on this first part here. If she drops the rock, meaning it has an initial velocity of 0, motion map kind of action here, so something like that. Well, it's got an acceleration, this is for the dropped rock, acceleration of -10. Initial velocity, if you're dropping it, just releasing it, then it has an initial velocity of 0. Final velocity, don't know about that. The delta y is, I don't know that either, but I do know it takes 4 seconds. All right, I got 3 things, so we're good. So delta y equals 1/2 at squared plus vit. So the delta y is -5 times t squared, and that's 0 because the vi is 0. So 5 times 16, that's 80, -80, so the bridge is 80 meters off the ground. So now for the thrown one, of course the acceleration is still the same. The initial velocity is, I don't know how fast she threw it, that's what we're looking for. Final velocity, don't know. But now I know the delta y because it's the same bridge, so that's still -80. And I know that when she threw it down, it only took 3 seconds. And we're looking for the vi here. So I think we got the same equation again. I'm out of space here, so I'm going to go onto this page. So delta y is equal to 1/2 at squared plus vit. That's -80, -5. Oh, I know the time. It's 3 squared plus vi times 3. And now it's time to do algebra. So -80 is equal to, that's 9, so that'd be -45 plus 3 vi. If I add that to the other side, I'm going to get -35 is equal to 3 vi. So vi is about, what's that, 11.7 meters per second, and negative, which makes sense because she threw it down. And that's it.